Dear students, in this presentation, we will see some more topics like constant, hash define, scope of a variable, and type declaration. In the last presentation, we have seen a variable, the meaning of a variable, uh, how that plays a role in the program, then how to display the value like string or how to format your data, how to define that variable, data types, why the data type is required, why we should know the data type, the size allocated for each of the data type. Now, in this presentation, we'll extend with some more topics like constant. We'll start with a constant. We all know why that constant, what is that constant? Like when we solve some kind of mathematical equation or physics equation or equation of any kind of statement, that equation contains some constant. The mathematicians or physicians, those they have introduced some constant. That constant plays important role. Why that name constant? It is a number, which is a key number whose value is unambiguous, like pi value. Yesterday, today, tomorrow, even after 1,000 years, pi value is same. In the same way, e value, mu value, like that. That is a big list. You can see any source to see what is that value. Suppose we are going to develop application, that application involves these kind of mathematical constants. Then how it is possible to define such constant in our program so that by any means that constant should not be altered. That value should remain same throughout the execution of program. That is the purpose of constant. In C, how to define a constant? How to define a constant? A constant can be a string, can be a number, can be an integer number, can be a floating point number, can be a character also. The qualifier const here in C, we use keyword const, const. That can be applied to the declaration of any variable to specify that its value should not alter. The value remains the same till the program execution. That identifier value is same. Variables can be declared as constants by using the keyword const before the data type, before the variable name. Like you can see here in a C program, I want to make this as constant. I should not anyone, maybe in the program, that should not be altered. Value should be same. When you are trying to modify the value, it should notify you the error message. Then how to define the constant? The data type that I wanted to have float. The keyword const is given. The data type data name is A. The value is 15.56. This value remains same. The value of A remains same. I can print it. When I'm trying to modify the value, A equal to A plus 1, and when you're running that program, you will get that error message, read only variable. A, here you made that as a constant, you cannot modify it. This is the process of modification, but when you compile it, it gives error message because A is read only, A is a constant. Okay, the syntax is simple. The data type, in this case float, keyword const, data name A, the constant value 15.56. Okay, next, the second topic is hash define. I can give a kind of symbol Whenever that symbol encounters in the program, value that is defined here is substituted. Now how to give that kind of symbol in C? That is possible with the help of hash define. Here it is very difficult for me to give value somewhere here. This may be given in the header file. Wherever this capital letter, case sensitive, wherever this val is given in the program, wherever val is encountered, this particular value is substituted. It can be a symbol or it can be a number. Okay. Now, in this program, constant is defined. A is constant. What is the value of that? The value is the symbol val. Now it checks whether val is defined in this hash define or not. When it is compiling, it checks val whether it is defined or not. Val is not declared here, but val is defined using hash defined. Yes. Any value is given there? Yes, that is 15.56. 15.56 is substituted here. Here afterwards, a value is 15.56. Suppose one more val is encountered somewhere here. Somewhere here, val is encountered. That is substituted by 15.56. Suppose my equation is val equal to val plus 1. We'll see what happens. Is that value defined using hash defined directive? Yes. What is that value? 15.56. The left hand side value is 15.56 is equal to val. Is it defined? Yes. It is substituted. Val is encountered. 15.56 is substituted here. 15.56 is substituted. Plus 1 as per the equation. What is the right hand side value? The right hand side value is 16.56. Are they same? Are they same? Right hand side value is 16.56. Who will say this is equal to 15.56? That gives the error message. So don't try to do this kind of thing in the program. It can be in the right side but cannot be in the left hand side because you have assigned that to constant. The next topic is global variable. The variable which is declared outside any function is global, whose lifetime till the execution of the program, whose scope is till the completion of the program. Here, my function name is main. My function name is main. The variable that I would like to maintain throughout the execution of main is a. So, how to do that one? It will be available to all the functions of this program. It is at the file level. In this file, this is available. Not just for main. Whatever may be the functions there, that can access this A. So, A is global variable. Global variables are defined outside a function. Yes, this is defined outside a function. Usually on top of the program. At the file level, in this program, outside the function main, A is defined. Global variables hold their values throughout the life of the program. They can be accessed inside any of the function. As I told, this A can be accessed by main, A can be accessed by any other function. Global variables can be accessed by any function. Main can access it or any other function can access it. When a local variable is defined and it is not initialized by the system, we must initialize it. Global variables are initialized automatically by the system. Like, suppose A is defined but not initialized. It is automatically assigned with the value, that is by the system. System automatically assigns the value. What is that value? For all numeric like integer, float, double, 0 is assigned. For character, null is assigned. So if you forgotten to give this 90, system will assign 0. Because a is of type integer, so 0 is assigned. As it is assigned here initialized, this value is taken. Now we'll test this program. Global variable is defined. Global variable is a, which is accessible to main also. There is a local variable which is defined inside the function. Local. I'm trying to access the value of a. A is it defined here? No. This a is not defined here, but it goes one level up. Is it defined in the global level? Yes. What is the value? Is it initialized? Yes. The value is 90. 90 will appear in the output. The next statement, you are accessing b value. B value. 100 is the value. This is how the global variable placed in the program. Global variable whose value will be available for all the part of the program, whose lifetime till execution of the program. Next, redeclaration of global variable. Here, a is declared outside the function main. So, a is global variable. A is defined but not initialized. A is defined with the data type int but not initialized. For global variable, this variable can be redeclared int a and initialized. So what will happen if the same variable is defined again and initialized? Previous declaration is ignored. Previous declaration is ignored. This is allowed, but this is not possible for local variable. Here, b is local variable. B, you are trying to redeclare it with the initial value 900, but this is not allowed. Compiler says that P already defined. You will get linkage error. Okay, linkage error, linkage error. And another point is that here global variable B is defined with the data type integer initialized, but as it is already initialized, you cannot redeclare it. Redeclaration is allowed only if it is not initialized. Redeclaration is not allowed if it is already initialized. For local variable, redeclaration is not allowed irrespective of initialization or not initialization. Redeclaration is not allowed. This is not allowed because you are trying to redeclare it. This is error because B is already initialized. This is okay because A is uninitialized. Okay. When you're trying to do this, you will get linkage error. But here, another definition of B there before this one. This is about redeclaration of global variable. So these points you should remember. Uninitialized global variable can be redeclared. Initialized global variable cannot be redeclared. Local variables cannot be redeclared. These 3 points you have to remember. Now, what is that scope? Scope of a variable. Scope in any programming is a region of the program where a defined variable can have its existence. Beyond that variable cannot be accessed. We'll go to the previous slide. Here, where B is defined, B is defined inside the main. So outside this main, it is not available. So B scope is within this main only. Now, where A is defined, A is defined at the global level. So its scope is throughout the program. Throughout the program. There are three different types of having this kind of scope. One at the block level, second at local, third one global. For example, in the previous case we have seen two things, that is global scope, whose scope is available till the end of the program. Local scope, whose existence till the completion of this function only. Nothing to do with the other one. It is local to this function. This is To complete program, this is local to the function main. What is that block level? Block level means you can see it here. Here I have introduced three variable. This is having global scope because A is available inside the main, even inside the block or to any function. Here function is not introduced. When I introduce function, I will show once again this example. Here A is global, it is available to all the part of the program. B is local, it is a function level scope. It is this scope of B is in this main only. If some other function is defined, that B is invisible. Next, I have created a block. Block creation is very simple. Use curly bracket open. To end that block, use curly bracket close. Here, I have introduced a variable C, whose scope is within this only. Here, C is invisible because there is a closing bracket. Okay. C is local, whose scope is still here only. Open bracket, close bracket. It is ending here. So it is the last stage, last point where C exists. After that, C does not have its scope. It is invisible. You will get error when you are trying to use it. You will get error. So if you are trying to compile this program by removing this comment, you will get the error because C is invisible. You are trying to access it. You are trying to access it. It lost its scope. Okay. B, where B is defined. B is local, so it is accessible. Where A is defined. A is not in this block, not in this function. Here it is defined, right? You'll see the output. When you run this program, A is initialized to 90, B is initialized to 900, C is initialized to 100. Block variable C, what is the value? 100. Function variable B, what is the value? 900. Global variable, it is accessible here also, so it is 90. Now my block is ended. Now we'll try to access other things. C is invisible, so I will not take any risk of accessing that. I just made it that as a comment. Now I'm trying to access B. In printf statement, I'm trying to access B. B scope still there. I did not change the value of B, so B remains same, that is 900. I'm trying to access A even from this function also. It is possible for me to access it. Value of A did not change, so A is 90 only. If I modify the value of A to say 900 something, it is possible. It is getting reflected. 90 is overwritten by 900, so we'll get 900. Anyway, leave it. We'll see that in the future programs. Next, type definition. I don't want to use this lowercase int in my program. I want to give different name for that. I can give different name with this typedef. In C programming language, we can use typedef to give new name. Okay. Even you can give XYZ also. You are going to define, you are going to redefine this with a different name. Okay. So actual data type is int. You are redefining with a new name called int. Here afterwards, I can use even int or uppercase int. Say int uppercase is used. If this statement is not there, if this statement is not there, this gives the error. This is a new data type, it is not defined, so gives error. As the statement is there, as the statement is there, type def is there, your defined type def for int. Actually, lowercase int is also equivalent to int in this program only. I made like that. Okay, wherever int is there, it is treated as lowercase int. So int is there, it should be treated as int. So int a, it is possible, it is fine. So you are trying to print the value of a value is 10, 10 is printed. Okay, now I'm going to see the size of that int. What is that int? Int is defined as int, so substitution happens. Size of int, what is the size of lowercase int? It is 4. It is 4. You can try all these programs. Next, L value and R value. I will take equation x equal to y. In math, we write like this: x gets value from y. Whatever the value is there, that is stored in x. X is a container. Y is also a container. How this is referenced? Say there is a memory whose address is say 1000. Whose address is 1000. For me, it is difficult to remember this 1000. I will be indicating with the name called x. This is x, container x. This gets a value from y. I will take one more container. This is y. Say whose address is 2000. Again, it is difficult for me to remember 2000. I will be referring that with the name y. Something is there here. Say 10. This says that from this container y, container name is y, whatever the data is there, that is 10, you copy this to container x. This is the meaning. This is the meaning. So this will work. Now I will go for one more statement. 10 equal to y. 10 is a constant. Y is a container. Y content is, so I will make this as 101. Let it be 101. Y's value, Y's content 101. Can I change the value of 10 to 101? Is it possible? 10 cannot be changed to 101. This is not possible. So, point that you have to remember, equation is written in this way: L value is equal to R value. The equal symbol has got two parts, left side part and right side part. Usually, left side is a container, right side can be constant or a container. Okay, say two statements I told. L value is equal to R value. Left side is a container, right side can be container or it can be a constant. This is also possible. L equal to R. R value are copying to L. That is possible. 10 you are copying that to L. That is also possible. Right side can be a container or right side can be a constant. We will see that in the example. A is my container like this, which is of 4 bytes, whose name is A. I made that value 10. Going to put 10 in this container 10. What you do? 10 is equal to 90. Is it possible to modify the value of 10? 10 equal to 90, not possible. So A equal to left hand side is a container, right is a constant. It is okay, possible. Suppose that if I declare one more variable B, I can write like this also. B equal to A. That is possible. B equal to A is possible. A value is 10. Suppose this statement is not there. A is 10. B equal to A. That is possible. It can be a container or it can be a constant like this. Okay. So in this case, if left hand side is a constant, then you will get error like this. Okay. With this, I'll be ending this presentation. In the next presentation, we'll see some more topics. Thank you for watching this.